So I'm going to explain how to do a binomial random variable probability. And I'm not really going to even explain what that is. We're kind of just going to jump into how to set it up and how to do the computation. But really what you need to know is that a binomial probability works when you're doing a fixed number of trials. So it's like you're doing the experiment. You're repeating an experiment over and over. And each time you do the experiment, the outcome is only one of two options. So that's why it's called binomial, like bi meaning two and nomial meaning numbers. So there's only two things that could happen either time. And a lot of times we kind of think of that as a success or failure, or a true, false, or yes or no. So if you can do an experiment and the answer is always yes or no, and the probability for yes is the same every time, so you might be thinking about flipping a coin, right? And did it land on heads? That's it. That's a yes or no question, and the probability presumably is the same every time. Should always be 50% if we're flipping a normal coin. In any case, what we're looking at now is not a coin flip, and we can tell because the probability is not 50%. But we could say that we're doing some experiment 7 times, and the probability of getting quote unquote heads or a success in the experiment is 0.4 or 40%, which by the way means that the chances of failure or a false coming up are about 60%, 1 minus 0.4. Now, the question we're being asked is, what's the probability that x, or the number of times we get true, is less than or equal to 1? And the thing we have to remember about this formula is that it cannot handle a less than or equal to, and it can't handle a greater than or equal to. It can only handle exactly a single number. So the way that this particular formula is set up, if we're using n equals 7, which means we're kind of flipping our proverbial coin 7 times, this formula, if we use all the numbers correctly, this formula might tell us, if we plug in 1, for example, this will tell us what is the probability of getting exactly 1 out of the total 7. But you might notice the question that we're being asked in part A is, what's the probability of getting less than or equal to 1, not just equal 1. So if we use this formula, it will tell us what's the probability of getting exactly 1 success out of those 7 experimental trials that we did. So basically we're just going to have to adapt this a little bit, and less than or equal to 1, if we can only use this formula on the top left, then we really have to do p for 0 and the p for 1, and then we'll just add them together. Right, so like, what's the probability of getting 0 successes out of this 7 trial experiment, plus what is the probability of getting exactly 1 success out of these 7 trial experiments. So hopefully this makes sense. If it's a less than or equal to, we actually got to be a little bit clever in what we're doing, and come up with something that's going to allow us to calculate the total probability. So in this case, we're just gonna start plugging it in. I'll do this one first. So let's say equals. We'll put this in. Yeah, I'll use a really big bracket, and then we'll copy this formula here that's on the top left. But I'll plug in 0 for x and 7 for n. So P0 is going to be 7 choose 0. So by the way, if you're familiar with combinations and permutations, this is exactly the same as 7C0, and that has a specific formula used in algebra, and you can look it up, or perhaps you have it memorized. So it's 7 choose 0 times the probability of success, which is 0.40 raised to the 0, right? Raised to the x. In this case, x is 0, times 1 minus 0.40, which we've already figured is 0.60, raised to n minus x. In this case, 7 minus 0. 7 minus 0. Okay. So all of this is the probability of getting exactly 0 successes, or 0 heads, in our 7-trial experiment. Remember, this isn't exactly flipping a coin because p is 0.4. So it would be like somehow flipping a coin, but the probability of getting heads is only 40%. So it's kind of like a weighted coin or an unfair coin. But we're kind of just using the coin thing as a metaphor. But okay, and now we're gonna have to add to this the probability for 1, and that's gonna be very similar. We'll use the top left formula: 7C1, 7 choose 1, times 0.40 to the first, times 0.60 to the 7 minus 1, which happens to be equal to 6. So this will simplify to 6. Okay. Actually, yeah, I'll just put a line through this, and this is equal to 6. Okay. So then what you would do is you would literally take this whole upper bracket and we would calculate it. I think it's actually pretty easy because 7C0 is just 1, 0.4 to the 0 is just 1, and 0.60 to the power of 7 minus 0 is actually just 0.6 to the power of 7. So all of this upper bracket just turned out to be whatever is 0.6 to the power of 7. So you can plug that into your calculator and pretty easy. This one also simplifies pretty easy. 7C1, just remember anything 1 is the other note. So it's actually just 7 times 0.4 to the 1 is really just 0.4, and then 0.6 to the 6th power. Okay? So you will evaluate the first bracket, you'll evaluate the second bracket, and then you just add them together. So I would just suggest, using your calculator and add these two quantities together. And then this should be your probability basically for x is less than or equal to 1. So we were kind of testing if x could be equal to 0 or x could be equal to 1. So that's kind of what x is less than or equal to 1 implies. So hopefully that makes sense. Now we might want to talk about how do we set up for b, because it's going to be related. So maybe I'll start doing this one in blue. It's the same formula, we just have to adapt. N is equal to 3, p is equal to 0.7. Oh, okay, so it is actually different. In that case, let me erase some of this. Okay. We'll just start over. Okay, so we'll do part B. And part B says n is equal to 3. So that means we're flipping a coin or we're doing some kind of experiment 3 times. And the probability of our experiment succeeding each time is about 70%, or 0.70. And now we're being asked, what's the probability that if we do this experiment 3 times, that we'll get a success more than 1 time? And again, if we see a more than or a less than, we got to adapt this slightly. So what we're going to do is we're just going to realize that more than 1, if we're doing an experiment of 3 trials, that's really just like saying, what's the probability of getting 2 successes in our experiment, or 3, either one of those would satisfy. And so we'll basically do the same thing. We'll just end up adding. So we'll calculate P2, which is like 3C2. Actually, I'll write it different this time just so you see it's the same. It's 3C2. In fact, if you know what you're doing, you could do this in the TI-84. I think it's math. I think it's under probability. And then you'll see one that says like NCR or something. So you hit that and then fill in 3 and 2. So you can evaluate this, or you can look up the formula on Google. 3C2 is easy to evaluate. If you know what you're doing, there's lots of ways about it. And then we're multiplying by probability for P, so that's 0.70 raised to the power of x, which is 2, times 1 minus 0.70, which is actually the probability of failing in our experiment, which is 0.30, to the power of n minus x, so that's 3 minus 2, which is actually just 1. And then again, we'll evaluate all of that. We'll evaluate this other one separately, P3, which is going to be 3C3 times 0.70 to the 3 times 0.30. Well, 3 minus 3 is actually 0. Don't forget, anything to the power of 0 is equal to 1. So it's kind of like all of this is just equal to 1. So you're just multiplying by 1, which doesn't really do anything at all. And just remember, you compute these separately. Plug them into your calculator, figure out these two, P2 and P3, and then add them together, because that's equivalent to the probability for x is bigger than 1 is the same as probability for exactly 2 successes plus exactly 3. And it's only 2 and 3 because we only did 3 experiments, so it can't be more than 3. Okay. Part C, I'll show you how to set it up, just because basically all these work the same, but we're using this kind of clever logic on part C to make it a lot easier. Because you might notice on this one we're doing an experiment, some kind of experiment 8 times, and the probability of succeeding any given time is about 60%. And they're asking us, what's the probability of getting less than 7 successes? So the probability of getting less than 7 successes, it looks pretty daunting, because technically that's what happens if you get 1 success, or 2, or 3, or 4, or 5, or 6. And that's a little crazy. However, there is one thing that we can say, and that is if we're doing an experiment 8 times, if we add up all these probabilities, like what's the probability of 1, 2, 3, 4, 5, 6, 7, and 8, well, that's everything that could possibly happen. If you figure out what's the probability of getting exactly 1 heads in a coin flip, or 2, or 3, or 4, or 5, or 6, or 7, or 8, well, that's literally all the possibilities. So the probability of this happening should be exactly 1, or 100%, right? Because if you add up what is the probability of all the possible things that could happen, it's always going to be 100%. So kind of using that logic, what we're going to do is we're going to say the probability of x is less than 7 is going to be like what's the probability of anything happening? So 1 minus P7 and P8. Because those are the two that are getting left out. Notice how it's less than 7, so it doesn't actually include 7. So we're saying, like, what's the probability that you're going to get less than 7 heads? Well, you could find the probability that you're going to get at least 7 heads. That's this part. So we're just finding the opposite. What's the probability that x is bigger than or equal to 7? 7 or 8. That's easier. And then we'll just do 100% minus that number. So same thing, you're going to find P7, you're going to find P8 separately. You'll add them together, and then you do 1 minus whatever you got for P7. So like 8, choose 7, 0.60 to the 7, 0.40 to the 8 minus 7 is 1. And then that gets, basically that gets added to 8, choose 8, 0.60 to the 8, and 0.40 to the 0. I don't have room for another bracket here, but it should be another bracket there to close everything off. So hopefully that makes sense. That's really the one that's going to be a little tricky. And you will definitely use the same logic for part D. Because if you notice, what's the probability on D? It says, what's the probability of getting x more than one true result in an experiment of 6? It would be easier to figure out what's the probability of getting less than 1, because the only option is exactly 0. So you can find the probability of getting no true result out of an experiment of 6, and then just do 100% minus that number should tell you the probability of getting more than 1. So hopefully this makes sense. I'm gonna stop the recording here, and yeah, just send me your questions or let me know if any of this makes sense.